Hi everyone, it's Jeff here, one of your CS2210 TAs, and I'm just going to give you a quick tutorial on a couple of tools that I built that will hopefully help you while completing assignment 5, just to make sure that your graph class works properly and that your map class creates a graph with the proper structure. Okay, so the first tool that you may find useful is the Graph Visualizer. Now this particular tool is going to come in handy once you've finished your graph class, and what you can do is compile your code with the Graph Visualizer code and then run it, and you'll see a window like this. So the first thing you'll want to do is go up to the File menu, click on New Graph, and then you can see that it's going to ask you for the number of nodes you want to place in the graph. So I'll just enter 4 to create a simple graph with 4 nodes. Now what this has done is actually created an instance of my graph class, passing in 4 to the constructor. And then what you see in this graph pane here is essentially a visualization of the internal structure of your graph object. So I'm just going to line up these nodes here. Okay, so once you have your graph created, the first thing you'll want to do is go into Edge mode here in the toolbar. And what this lets you do is just select any pair of vertices or nodes in the graph, and it calls the insert edge method on your graph class, passing in the nodes that you selected. Okay, so I'm just going to create a couple of these, and that looks good. You'll also want to check to make sure that if we try to insert an edge between a pair of nodes that are already joined by an edge, then as per the assignment spec, it should throw a graph exception, which it has done here, saying that the edge already exists in the graph. So just make sure of that. You can also go into detail mode by going up to the view menu and clicking show detail, or you can just press D to toggle between those two modes. And this actually uses a facility in Java called reflection to take a look at the internals of your objects, to look at their instance variables and the values of the instance variables. So you can see here that my node class has an instance variable name and an instance variable marked, and my edge class has instance variables endpoint 1, endpoint 2, type, and label. So you just want to make sure that these are all correct, they have the correct values. For example, I have an edge between nodes 0 and 1, so my endpoint 1 variables are set to node 0 and node 1. If that were to say, for example, node 3 and node 5 on an edge between node 0 and node 1, then obviously something's not right there. So you just want to make sure that all of the values of your instance variables are correct. Let's go now to check mode, and what this allows us to do is select any pair of nodes, and it will call the RAdjacent method on your graph class to check if the two nodes are joined by an edge. So these ones have an edge between them, so RAdjacent returns true. Now I selected 0 and then I selected 1, and that passes in node 0 as the first parameter and node 1 as the second parameter. You also want to check it the other way around. Let's check node 1 as the first parameter and node 0 as the second parameter, and that should also return true because it's an undirected graph. Finally, we also want to check to make sure that if we select a pair of nodes that are not joined by an edge, then RAdjacent should return false, which it does. So that looks good. Now, if we get out of check mode here, you can select a vertex and you can take a look up here. Now what this is it shows you the output of the incident edges method. So I selected node 0, and then the visualizer tool called the incident edges method on node 0, which returned these edges, 0 and 1, so that edge, and 0 and 2, which is that edge. So that looks good. So you just want to make sure that that's reporting the appropriate edges for the node that you have selected. Okay, so node 1 only has an edge between 0 and 1, so its incident edges method only returns that particular edge. Okay, the last thing that you'll notice here is in this graph edges pane, you have a list of all of the edges in the graph. So this is actually obtained by iterating through every node in your graph, and for each node in the graph it calls the incident edges method on that node, and then it takes all of the edges that were returned to it, takes out any duplicates, and shows you a list of all the edges you have in your graph. So it gives you a count of the edges that were returned by your incident edge method, and it also shows this max edges here. Now what this is if we have a graph, a simple undirected graph with n nodes, then the maximum number of edges that we can have in that graph is equal to n times n minus 1 over 2. Okay, so we have here a graph with 4 nodes. So the maximum number of edges that we can have is 4 times 4 minus 1 over 2, which is 12 over 2, which is 6 edges. Okay, so in a graph, in a simple undirected graph with 4 nodes, we can have a maximum of 6 edges. Now, why do we care about this? Well, it's a simple sanity check. You want to make sure that the total number of edges that your graph is reporting is always less than or equal to the maximum number of edges. So if I, for example, were to click this complete graph button to create a complete graph, and for some reason your graph were to be reporting 12 edges, then that's going to be indicative that there's a problem there, because the maximum number of edges, again, in a simple undirected graph with 4 nodes is going to be 6. Okay, so you just want to make sure that this number is always less than or equal to that number. The next tool I want to show you is the map visualizer, and this tool will come in handy once you've finished your map class. Okay, so the first thing you want to do is go up to the File menu and click on Open Map File. And then you can just select one of the map files that were posted on the course website. So I'll load up map 1. Now what this does is it creates an instance of your map class. It passes in that map 1 file. Your map class then goes and loads the file, reads it, and creates a graph based on the contents of the file. And then what's being displayed here on screen is a visualization of the graph that was created by your map class. So you want to make sure that it has the appropriate structure. So you can see in the map 1 file we have roads joining these nodes, and we have edges between those nodes in the graph, so that's good. You can also go into detail mode once again, and you can take a look at the types of edges that you're creating. So you can see here we have a dash between node 0 and 1, so we should have a free edge right here. That's good. We have another dash between nodes 1 and 2, so we should have a free edge here. That's good as well. But then you'll notice that we have a vertical toll between nodes 2 and 7, and of course that's also showing that we have a toll there, so that is good as well. And then if we pan over just by grabbing it and dragging, you can see we have another toll edge between these 2 nodes here. So you just want to make sure that not only is the structure of the graph that your map class is creating, you want to make sure that it's correct, but also that it's creating the appropriate types of edges based on the map files. Okay, so just to give you one more example here, I'll go to File and load up map 2. And this has a bit of a different structure. We don't have edges between every node. So for example, between nodes 2 and 3, there's no road there, so therefore there's no edge in the graph between those 2. Okay, and just down here we have a horizontal toll between 12 and 13. So if we go into detail mode and we pan down there, that should show up as a toll, and of course it does. So that looks good. So hopefully this tool just helps you to make sure that the graph that your map class is creating actually corresponds to the map file that has been loaded. Okay, good luck with your assignments, and I hope you find the tools useful.